Hello and welcome to lesson 4-6 on rational numbers. In tonight's lesson, we have two objectives. First, you will be able to identify and graph rational numbers. And secondly, you will be able to evaluate fractions that contain variables. So this was a warm-up of yesterday's lesson, where we had to simplify or put fractions in their simplest form. All right, as a warm-up, well, I'm just going to go through couple of these just as a little reminder. In order to write in simplest form, you divide. And we have to look at the numerator and denominator in number one. We have 2/10. Well, we need a number that goes into both. Well, that would be 2. So, because they're even numbers, we know 2 goes into both. 2 divided by 2 is 1. 10 divided by 2 is 5. You get 1/5. All right, so that's a little reminder of what we did yesterday, and it could come in handy in today's lesson. So first, before we begin, I need to talk to you about what rational numbers are, or the categories of numbers. All right, first we have whole numbers, and those are the numbers that start with 0 and they're positive whole numbers. So 0, 1, 2, 3, 4, and so on. All those are considered whole numbers, starting with 0 and all other positive numbers that are whole. Then we have integers, which we really worked on in chapter 1. Those are the positive and negative whole numbers, and it includes 0. Rational numbers now are any numbers that can be written as a fraction. For example, we can change any whole number to a fraction. All we need to do is think, well, if I have the number 2, what can I put on the bottom that doesn't change my answer, that it still values it as 2? If you think of the identity property, it's 1. 2 over 1 is the same thing as 2. So 2 can be written as a fraction of 2 over 1. You could do the same thing here with -6. Well, if I put it over 1, it's still -6. It's just written as a fraction. So any whole number that can be written as a fraction is a rational number. So here I have a little category piece for us, and we need to decide where each one goes. I have my rational list, I have my integers, and I have my whole numbers. So 0, all right, we can do this one together. Well, 0 is considered a whole number because it's 0 and up. 0 is considered an integer because that's a positive or negative whole number. And 0 can be written as a fraction, 0 over 1. So it's a rational number. Now go ahead and do the same thing with -5, 6/7, and 3/3. Decide if the numbers are whole numbers, integers, or rational numbers. A couple of them can go to a few different categories. So go ahead and decide that now. All right. So if you were to do this, -5, well, it's not a whole number, but it is an integer. And it is also a rational number because we could write it as -5 over 1. Still means -5. Now 6/7 is not a whole number because it's not a whole number. It's not an integer because it's not a whole number. But remember, rational numbers mean any numbers that can be written as a fraction. Well, 6/7 is listed as a fraction, so of course it fits. 6/7 is a rational number. Then we have 3/3. Well, right away I can say yes, that's a rational number because it's written as a fraction. But if we simplify this, it could also go in other categories. 3/3, if we simplify it, well, I know 3 goes into both. And I'm left with 1 over 1 or just 1. So 3/3 actually equals 1. So 1 is a whole number and it is also an integer. So that one can go on all 3 categories. So, for any rational number, there's an unlimited number of equivalent fractions because you could multiply it by any number up to anything, and it's still equivalent. So for one here, it says, write 2 lists of fractions equivalent to 2/3. No, they want 2 lists. That means they want a positive list and really a negative list. I'm going to show you that in a moment. But we can start with, well, I know 2/3. There we go. All right, well, this is 2/3 times 1. If I times it by 2, well, 2 times 2 is 4. 3 times 2 is 6. I could times it by 3. 2 times 3 is 6. 3 times 3 is 9. I could times it by 4. 2 times 4 is 8. 3 times 4 is 12. Again, as long as I multiply both the top and bottom by that number, it's equivalent. I could do 5. 2 times 5 is 10. 3 times 5 is 15, and so on. So that's one list. Now, we could also make a list of negative fractions because we've talked before about positive and negative numbers. A number, when you multiply, a number is positive if both numbers are the same. So 2/3 is positive, but if I made both numbers negative, if I switch this to -2 over -3, well, if I divided that out, that would be a positive answer. So here, because it is positive, I could have another list of negative numbers. Well, I could times this one by 2. -2 times 2 is -4. -3 times 2 is -6. -2 times 3 is -6. -3 times -3 is -9, and so on. -8 and -12. So all of those are equivalent. There's my two lists. I have my positive list and my list of negatives. And then finally, down at the bottom, write 3 fractions equivalent to -4/5. All right, when I like to do ones that are negative, they can't ask us for 2 lists anymore because it's no longer a positive fraction. All right, we can only have 1 list. I like to assign that negative sign to the numerator. All right, because when you talk about a negative number, that means only one of those is negative, not both. If both are negative, you end up with a positive number. So I assign that negative sign to the top, and now I just start figuring out an equivalent fraction. Well, again, I could multiply by 2. -4 times 2 is -8. 5 times 2 is 10. Let's see, I could times it by 3. -12 and 15. There we go. All of those are okay. All right, all 3 of those are equivalent. So moving on. Now we can compare and also order rational numbers. And one way you can do that is with the number line. Figure out where each one goes, and then from there, well, smallest to biggest, it'll tell you. Now something that I like to do is I like to switch them into decimals because that really does help me out. So if I divide 3 by 4, all right, I have to add a decimal to 0. Well, I get 7 times. That 4 goes into 30. Added 2, go down. Oh, -3/4 is really -75/100. All right. So I could graph that one. Well, -75/100, I know that's between 0 and -1 because it's not positive, but it's not quite 1. So here is where -75/100 is, or -3/4. Same thing. All right, then I could do the same thing to 5/10. Well, 5/10 is between 0 and 1. Halfway, in fact. 5/10 is the same thing as 1/2. Or 5/10. There we go. And then we have 0. Well, 0 is right on there. That's an easy one to plot. And then we have 1/3. Again, which I can divide out. Well, 3 goes into 1 0 times, but 10 9, or 3 times to make 9. And this one is just going to keep on going. So this is 0.3333. So I take a look. Oh, that must be right here. Because it's between 0 and 1, but it's not quite 0 and 5/10. So that is where 1/3 would be. So now I can list them. Well, the first one I had, the most negative, is -3/4. Then I land on 0. Then I'm at 1/3. Then I'm at 1/2. There we go. So some of you might be able to just figure out where they go, but other people, like myself, like to switch them to decimal. Do whatever works better for you. Now here's this one. You need to graph each rational number and then order from least to greatest. So just like what I just did. All right, so you go ahead and do this. And when you're all done, come back and check it out. So pause me now. All right, so let's check this one. For A, we have -1.5. Well, if you switch that to a decimal, if you divide it out, it's -5/10. But I also know -1/2 is between 0 and -1. There we go. Then I have -4/10. Now this one might be a little more difficult. Let's see, I could divide that one out. And let's see, I'd add a decimal. 10 goes into 40 4 times, but it's a negative, so this would be -4/10. All right, and that is a little less negative, so that goes right in here. So negative 4/10, because this is negative 4/10 and that is negative 5/10. So 1's a little closer to 0. Then we have negative 2, which is right on the line. Then we have 9/10. Well, 9/10 is right between 0 and 1, but it's pretty close to 1. There we go. Now I order them. I have negative 2, negative 1/2, negative 4/10, and 9/10. There we go. That's listed from least to greatest. Now, the second piece of our lesson talks about how you can evaluate fractions when there are variables involved. All right, and sometimes what ends up happening is you have work to do at the top. For this example down here, I have at the top in red 1 plus 9 plus 2. And then it says divided by 2 minus 5. Well, you can't really do that at this point because there's so much going on. So what you need to do is you have to simplify the numerator and denominators first. So if they're doing some addition, if they're doing some subtraction, whatever they're doing, you need to simplify that first. Then at the end, simplify the whole thing. See if there's any ways you can reduce your fraction. So here, I have 1 plus 9 plus 2. I'm going to simplify the numerator. Well, 1 plus 9 is 10, plus 2 is 12. All right, now I do the same to the bottom. 2 minus 5, well, those are opposite. 2 is positive, 5 is negative. So 1's positive, 1's negative, I meant. So I have to subtract them. I get 3. Well, 5's a bigger number, and there was that minus sign, so negative 3. Now, this is much easier to solve than this one, because otherwise, there's so many numbers, so much work going on. So you want to simplify first. So I'm going to go ahead and do that. Well, 12 and 3, I know 3 is a factor of both. So I'm going to divide by 3 to simplify it. 12 divided by 3 is 4. 3 divided by 3 is 1, but this is a negative 1. All right, so we get 4 divided by negative 1. However, as I said before, any fraction can be written over 1. If you divide this out, 4 divided by 1, well, it goes in 4 times. So our answer really here is negative 4. There we go. So here's an example of what I was just talking about, where we'll have to simplify before we actually solve. A fast sports car can accelerate from a stop to 90 feet per second in 5 seconds. What is its acceleration in feet per second, which means feet per second squared? Use the formula A is equal to F minus I divided by T, where A is the acceleration, F is the final speed, I is the initial speed, and T is time. So we know we're going to use this formula. A is the same as F minus I divided by T. And again, they tell us what each piece is. A is the acceleration, F is the final speed, how much it went at the very end, I is how much it was going at the beginning, and T is the amount of time it took in seconds. So if we wanted to evaluate this, this means we have to first put in those numbers they give us. All right, so I want you to try to figure out where every piece goes, and then when you're all done, come back and check it. See if you have it in the right order. And when you're all done, we're going to solve it together. So go ahead and set it up now. So pause me, please. All right, so let's check this out. Well, final speed. All right, I know that the final speed we went is 90 feet per second. The initial speed, well, it tells me it from a stop to 90 feet per second. That means we weren't going at all to begin with. Our initial speed was 0 because we weren't moving. We were stopped. And our time, well, it took 5 seconds. All right, so if I wanted to find out what my acceleration is, I need to go ahead and solve this. Well, 90 minus 0, I have to simplify the top, is 90. And time is 5. I can't simplify that, so I divide it out. 90 divided by 5. Well, 5 goes into 9 once, and 5 goes into 40 8 times. So subtract that out, and I get 18 feet per second squared. Because it says up here, what is its acceleration in feet per second, or feet per second squared? And that would be our answer. All right, and that brings us to the end of our lesson. So in tonight's lesson, we looked at rational numbers and how we could make lists by doing equivalent fractions, graphing them and ordering them, and finally simplifying fractions in order to simplify. So I will see you in class tomorrow. Bye-bye.